Thank you very much, Dimitri, and thank you for inviting me to speak. So, yeah, my name's Ben Gafner. I work for Jacobs, and I'm a senior mechanical designer. And I was brought on to help lead the team implementing the visualization tools on engineering projects. So, Jacobs is in the UK is a nuclear decommissioning company, and we work with companies like Sellafield and Dounreay on their legacy facilities in dealing with their historical waste and implementing new processes. So a lot of the things that we have to interact with in terms of starting new projects is we have a lot of legacy buildings, old buildings that don't have, all this fancy 3D model data that comes along with them. A lot of them just have a significant amount of them, unfortunately, just have 2D drawings that were hand drawn in some cases that have been photocopied several times, and then integrating that with new build, whether that be with inside existing buildings or an addition as lean-tos to support processes for importing, exporting, or managing nuclear material. We do this from the concept phase or the preliminary phase all the way through to commissioning, operations, decommissioning. So it's the full life cycle of the projects that we offer as a company um, across all disciplines. So a little bit about visualization and what it is for Jacobs is the way we see it is trying to get everything that we've been doing historically and bringing it to as many people as possible in the most comprehensive way possible. So, like I said, we take projects from the feasibility stage, the prelim design stage, all the way through to decommissioning. And that's something that we have to take in, decommission is something we have to take into account when we're designing our facilities, that we can show and demonstrate that they've been designed to be dismantled safely in a safe and environmentally safe manner. Um, and for the visualization aspect, we see this as introducing animations of processes, um, of finite detailed movements, interactive engineering models for design reviews and human factors reviews. This coupling with digital twinning for construction and maintenance that slowly gets built over time with functionality added as the project progresses. And then in the end, training and operations tools, whether that be virtual reality or just interactive animations, like I mentioned earlier. These are all things that we're looking into implementing into the package that we offer as a company. Previously, like I've said, we deal with a lot of historical drawings that are very dated, have been photocopied multiple times. If we want to get information across, we'll put PowerPoint presentations together. Maybe we'll have 3D models that people have produced or vendors may supply, and we'll have still images of those. And what's most likely is just wordy documentation of processes like mechanical flow diagrams, sequence diagrams, business execution plans, everything like that, everything that people will be familiar with. What often happens with documents like those is there's a lot left up to interpretation. Retention isn't very good. And it can be a slog sometimes to get the nitty gritty detail of how a process works and get somebody up to speed. And that time is money because it takes that person a long time to get up to speed. And often what happens is the image built up in one person's mind might be completely different to an image built up in another person's mind. And that may only be realized later down the line once design has begun and we've started to create 3D models for people to actually see. So currently what we do is we use, from a visualization perspective, we use Unreal Engine at a very early stage in the project, and we use that to basically where we wouldn't typically have 3D models because the engineering may not have started. This may be just a feasibility study, a study into, what needs to be done, what are the access routes, what equipment needs to be moved, what waste needs to be handled. Not something where stereotypically engineering would be involved in the design aspect. We've involved a visual media team using Unreal Engine to create those 3D environments and bring them into life for people to actually witness. I'll just play a little animation, a little video now. I'll just have that playing in the background while I kind of talk further about what it is that we've been doing. So this example, for instance, is very early doors. We had no 3D models. We had models from vendors. Um, that you can see. And they were implemented into Unreal Engine, and it allowed us to make a visualization before there was any actual engineering work done. Um, Now, within that, we can use 3-point cloud data. We can use engineering models as the project progresses. So we can use it as we kind of like build this up as we go. And recently we've been using LiDAR and photogrammetry, and we've not used it in Anger yet, but what we're looking to use it for is a kind of an iterative process during a commissioning phase where we can very, very quickly get a view of where the build is up to and then feed that back into our live models. On top of using this for the visualization, we've also been using Reach from a more engineering standpoint. So Vitalis Reach is like an end tool where we create our 3D models in our chosen packages, whether it be Inventor, Revit, CAD, AutoCAD, Aviva, SolidWorks, etc. And then we can put them into Vitalis Reach, and that allows us to access those models through a web browser interface. Historically, we've done, and we still do, design review meetings using a tool called Navisworks for visualization and collecting multidiscipline models into one space, which is fantastic. But what Reach allows us to do is go one step further, and it allows each user to have their own instance. So rather than having one model up on a screen that is shared and then one person moving around and showing everybody what's going on, it's almost a collaborative space where people can enter into the model themselves, move around freely themselves. We can grab their attention when we want to, highlight things where we would like them to look, um, and use that as a more interactive way of reviewing the design. And with the comment tool that it allows you to use, we can leave comments, so we can capture everything that was said with inside the meeting alongside meeting minutes that we would do historically, just to add more depth and knowledge uh, to to take away from the meeting. Um, Once the meeting has finished, that same instance of that model can then be shared with everybody, including people who couldn't make the meeting. And what it allows them to do is they can go in at a later date and make those corrections or make those comments or add their input with full scope of what was said in the meeting, what was referred to. It allows us to see from the perspective of the person making the comment. So it just allows somebody who was not able to attend the meeting a closer insight to what was said and why it was said during the meeting, something that we've not really been able to have before, other than recording an entire meeting and letting somebody sit and review that. And then obviously we can monitor through that what version of the model was used at what meeting, and that just gives us records for us to keep track of and reference if we wanted to. Um, I'll skip ahead in the video short. So um, one of the things that we've been looking at is obviously 4D and 5D modeling, and this is arcing back to the digital twin that I was talking about earlier that we're trying to implement now, start at an early stage and put as much information in as we can from the beginning and just keep building that on top of it, because trying to shoehorn this information in at a later date is very difficult, and costly, time consuming, and people don't often always see the value of it. But if we can build it in early, then that's what we plan on doing. So going forward, what we really want to do is offer digital as a service, which basically means right now what we've got is we have engineers on projects who often do the BIM coordination, who often produce these visualizations, produce the animations. And as a demand for these visualizations and interactions is increasing, so is the software becoming more specialized. And what we really want to do is we want to leave our engineers as engineers, and we want to create a digital team that can then support each project individually. And the additional benefit of doing that is it allows us to pool all of our knowledge and learning from experience from current projects that we're working on, projects we've worked on in the past, and apply that to projects going forward. So we have this iterative process where we're always learning and implementing new means and ways of working. And because it's not just engineers who are doing this job for us, we can keep on top of the latest and greatest technologies and implement it in the next project that comes along, and we're not training up an engineer who is then sat on one project for 2, 3, 4 years as some of our projects take that long, sometimes we can lose that knowledge within a project, when it could be maybe used better elsewhere. Um, and as I've said, we currently use Unreal Engine quite heavily, in compared to Visionary Render, and that's purely just us based on us not having the training yet. And our idea is, because we use Visionary Render as a stepping stone to get to Vitalis Reach, we will use Visionary Render to put out these animations to introduce our digital twin from the initial stage. So from the get-go, all of our data will be going into Visionary Render, that will just be updated as we go, and we'll introduce things like process flows. We can see bottlenecks. We can look at adding maintenance schemes, construction sequences, all within the same model that grows with time. That's the plan, and then continue then to push that one step further into Reach, to allow us to continue to support our design reviews, our people working on site, and just making it far more accessible. So currently our Reach server is local. We have a local server set up, that Vitalis help us integrate into our systems, and anybody on the Jacobs network now can access our Reach server. And I'm currently in the process of getting that server access external. So if we are on site and we speak to clients, we can just quickly send them an invite and show them exactly what we mean, while still maintaining the actual physical server on our side. And as I've mentioned, and I've said throughout this, that Reach gives us the ability to reach as many people as possible. And the main benefit from this that I've seen so far is, the earlier we can get eyes on to what we are picturing and what the end goal of the design is, what the process is going to look like, the sooner we can get decisions made, the sooner we can catch little things out, little incidents out, things that would historically have only really come to fruition at a later stage of the project, when we are actually designing these and we are actually modeling these and we're having these multidiscipline design reviews. And at that stage, a lot of time and effort has gone into design, and it's very expensive to roll back that clock. So rather than having a constant circle of an iteration, we've almost got like a spiraling wave approach, where we'll do a little bit of design and then review it, and then a little bit and then review it. Instances of where we've already seen this come into play. One of the examples that you saw at the beginning of the video, we had these grit blasters, which are a COTS item. We buy them in, and the vendor had the models, had them all modeled up. So we had a very detailed model to be able to put very early doors into a facility that the visual media team modeled up. So it wasn't based on engineering data, but the vendor's items could be put in. And when we modeled the throughput process that they were planning to remove and install new equipment, we saw very quickly that there was not space for these blasters to go in. And if we did put them in, access to some of the pipework behind would have been very, very hindered, and inaccessible in certain places, which, again, like I said, would not have been spotted that early on in the project. That was done before any drawings had been produced. It was just mechanical flow diagrams. It was just text in boxes. It was just documents at that stage. So that allowed us to implement an important change that would have definitely cost time and money further down the line. And I'm not saying it wouldn't have been caught. It definitely would have been caught, but it's the stage in which we catch those, and then the implications of redesign at that stage. Um, and it allows us to just work collaboratively. So, you know, we have 2D drawings as a very base. That's where we started, and then we had these 3D models. And depending on the model, you might need a more powerful computer. We have Navisworks that makes our engineering models very light. Reach just takes it that one step further, and it just removes barriers to entry. So you don't need, you don't even need a computer. You can do this through a phone or a tablet or a VR headset. um, it allows it to just be more accessible, and there's less reason for people not to be able to view our models on a regular basis. And it's all coming from the engineering data, so we're maintaining that single source of truth. And it just allows everybody to see it, and when everybody can see it, there's far more chance in catching mistakes early doors from disciplines like say human factors involvement from a very very early stage, they could just be passing and see something and make a comment, and we could implement changes based on that. Again, something that wouldn't have been caught further down the line. So that's our kind of my quick rundown of what we have done, what we're currently doing, and what we plan on doing. Um, if any of you have any questions, I'll leave my email address up on screen for anybody to send me a message and contact me. Um, yeah, feel free to send me any messages and or contact Vitalis, and they can pass messages on. But thank you very much for listening.